Welcome to another physics class. During our last lesson, we looked at force, mass, and acceleration of a body under Newton's second law of motion. And by then, we look at the effect of mass and force on acceleration of the body. Then we said from Newton's second law of motion that F is equal to ma. We now say that A will be equal to F over A. In this case, we now concluded that force can affect acceleration. At the same time, mass of the body can affect acceleration in the sense that the A is directly proportional to F. That is, if the force of an object is increasing, then the rate at which acceleration also will be increasing. At the same time, we stated the effect of mass. A is inversely proportional to M. That is, if you increase the mass of an object, definitely that increase in mass will lead to decrease in its acceleration. That is, the bigger an object is, the lesser its acceleration and vice versa. Now, today our topic is impulse and momentum change. And don't forget, this topic is the continuation of the one we've done before. Now, if you want to enjoy the class, please try to like, share, and subscribe so that when I have a new video to be uploaded like this, you'll be able to see the notification in time. So, impulse and momentum change. So, as I said in our last lesson, from Newton's second law of motion, we've already known that F is directly proportional to delta P over T. That is, the delta P is change in momentum, while T is time taken. Now, from this expression, we can now say F is directly proportional to P. At the same time, F is inversely proportional to T. Combine these two together, then we are going to have F is directly proportional to delta P and inversely proportional to T. Now, from this one now, we can now say that F is equal to K delta P over T. Mind you, we said under this topic, K is a constant. So if you remove it, it has no effect on the equation. So from there, we can now say Ft will be equal to delta P. And if you can still remember, delta P is what meant by change in momentum. Change in momentum. And from our topic, impulse and momentum change, this quantity, Ft, is what we term as the impulse. That is, I, which is impulse, is equal to Ft, which is equal to delta P. That is, the question asks you to find the relationship between the impulse and the momentum. This is how you are going to relate the two quantities together. You can now say where I is equal to impulse, then the formula can be the force multiplied by the time, or it can be equal to change in momentum. Therefore, this one we can now lead us to definition of impulse now. Definition of impulse. So from our equation and expression on the board, we can have two definitions. The first one, as we said, I is equal to Ft. So in this case, impulse can be defined as impulse can be defined as the product of force applied to a body and time taken for the force to be applied on it. That is the product of the force and the time taken for that force to be applied on that body is the first definition we can have under this topic. And from this one, we can now say that the unit of impulse, unit of impulse from this point, since the unit of force is Newton and that of time is second. So we can now say the unit of impulse can be Newton second. That is NS. That is from this first definition. Definition, which is number 2. Impulse can be defined. Impulse can be defined as the change in momentum. Change in momentum. Momentum, that is delta P of a body acted upon by force for a given interval of time. That is, it can also be defined as change in momentum of a body acted upon by force for a given interval of time. That is the second definition. Therefore, from this one, we can now say I is equal to delta P, that is, which is equal to M V minus MU. Then this one will now give M into V minus U. And from this one now, the unit of impulse, unit of impulse, now will now give us, since this one is kilogram and velocity is meter per second, so it can be kilogram meter per second. That is kilogram meter per second. That is the second definition and the unit from the second definition of impulse. And from what we have said so far now, we can now say that impulse can take 2 units. The first one, Newton second. The second one, kilogram meter per second. And from this second one now, we can now say that it is this second one that join impulse to momentum. In that case, they have the same unit. So that's one of the similarity between impulse and momentum. They have the same unit as kilogram meter per second square. And mind you, momentum cannot take Newton second. So that's one of the difference between them. Now, the next thing is examples of impulse and their application. Examples of impulse and their application. As shown on the screen, the first one on the screen is airbag. That is airbag. This one is a design in a car when there is head-on collision with another object. Then the airbag, or another typical aspect, is a bumper. So this one also will reduce the impact force and increase the impact time. So when the impact force is reduced and the impact time is increased, this one will minimize the injury that's supposed to occur. As I said, the design of airbag or bumper in a car during collision increases the impact time and reduces the impact force, so to minimize the injury. Number 2 on the screen is padded surface. Padded surfaces, that is in sport like gymnastics or pole vaulting. The padded landing area is increased, and when the padded landing area is increased, the time taken to stop also will increase. Therefore, once the time taken to stop is increased, it will reduce the force on the athlete and preventing the injuries. This, what we are saying in essence is that the padded surfaces will increase the time for the athlete to stop, and at the same time reduces the force so that the injury will be prevented. Now, number 3 on the screen is bungee jumping. Bungee jumping. Bungee cords are elastic in nature, and once it is elastic in nature, when it is being applied, it will increase the time it takes to stop and reduce the force on the jumper. And once the force on the jumper is reduced, then it will prevent the injury. Then the next one on the screen is hitting a baseball or a golf ball. When this one is being played, the player will first stretch his hand back. That's what meant by a follow through in a swing, increases the time of contact. And when this one increases the time of contact, then the ball will result in a greater impulse and move faster, further travel of the ball, and that is lead to the greater, faster travel of the ball. Next is a carrot stop. Carrot stop. As we know, a carrot stop is a fast, forceful action. So the fact that it's a fast, forceful action, it reduces the time of contact to 0. It reduces the time of contact to 0, being a forceful and fast action. And once the time of contact is reduced to 0, then this one will now result to a large force that can break material. Now, the last examples and application of impulse on the screen is during collision. In collision, the force is applied over a short time interval. And when this force is applied over a short time interval, it causes the change in the momentum of the colliding object. Here are the few examples of impulse and the application of momentum as explained on the screen. Next on the screen is impulse momentum theorem. Impulse momentum theorem. This theorem is trying to establish the direct relationship between impulse and momentum change. That is, what is the relation between the two quantities? This theorem tries to explain it. And the theorem states that the impulse acting on a body or an object is equal to change in momentum of the object. That is, the theorem states that the impulse acting on an object is equal to the change in momentum of that object. That is, I is equal to delta P. As explained on the screen, which has already explained before, that from Newton's second law of motion, F is equal to delta P over T. Then from there we can now say Ft is equal to delta P, which is equal to change in momentum. We can now say that according to that theorem now, that the impulse of an object is equal to the change of momentum of that object. We can now say that I, which is the impulse, is equal to Ft, which is equal to change in momentum. Whereas this impulse is equal to Ft and delta P also is equal to change in momentum. That is what the theorem is trying to explain. It shows clear relationship between the impulse and the momentum. And to conclude this aspect today, if you have been following us right from the momentum, we say momentum P is equal to 1. Momentum P is equal to mass times velocity. That is momentum. Then from there, we move to change in momentum, theta P, which is equal to mv minus mu, and where this mv is final momentum, and this one is initial momentum, and from there you can now say our delta P is equal to m into v minus u, since mass is constant. Number 3, we said from Newton's second law of motion, from Newton's second law of motion, we arrive at this formula: F is equal to delta P over T. F is equal to delta P, and don't forget our delta P is change in momentum, where our T is time taken. So we move further, that is number 5, by saying, if we now cross multiply, we now get another quantity, I, or before then, we arrive at, from the same Newton's second law of motion, at F is equal to ma. And we try to state that A will be equal to F over m. Then we try to explain the effect of force and mass of an object on its acceleration. So from there, today we arrive at, which will be number 6, that from this point we have our I is equal to Ft is equal to delta P. That is, I is impulse, where our I equal to impulse, and which is equal to Ft, where this delta P is change in momentum, as we said the other time. In our next class now, our work will be based on this formula. We want to look at calculation in which we are going to apply all this formula. So we are going to solve some problem based on momentum, Newton's second law of motion, and impulse and change in momentum. That will be in our next class. As I said in the beginning, if you are just joining us, please don't forget to like, share, and subscribe. So when I upload a new video like this, you'll be able to get the notification in time. Thank you.